animal intelligence. I guess we're not talking about animal intelligence directly, but something that struck me as I've been doing the interviews this season is how programming, that is the learning of the craft, and I guess this is rather obvious, but that's not priority one for everybody in the biological world. You can't do machine learning without coding. Well, I guess you can just do linear algebra on the chalkboard. But it did give me the thought that this season we could have a companion episode here talking all about the craft of programming. Well, maybe not all about, there's a lot to say. I'm going to talk to 3 people at different points in that journey, and then at the very end I'll share a few tips of my own for how to get going. First up is my co-host this season, Becky, then on to Malia Guillen, and last but not least, John Wilmus. So let's jump straight away into those interviews. There's a common first question I'm going to ask everyone I talk to, and it's, when is the first line of code for you?
Well, does it have to technically be code? I know that's a weird question.
Well, yeah, say more.
It could be code-like, maybe.
Okay.
So the first introduction I had to anything like code was an HTML and CSS class
Sure.
in college. And I know that's not technically coding, but to me, that was dipping a toe into it. After that, I would say I've done a little bit of coding in R. I've practiced a little bit of Python. And of course, the first code that I've written in all 3 of those things is Hello World.
And what's your, I guess, journey been like? Has it been an exploration of curiosity or always directed towards academic needs?
It has not been always directed at academic needs. So at my last job, I managed software developers and we were building custom applications for museums for an educational sense. So I'd say the first time I really jumped in with them, they couldn't always build out a CMS, a custom CMS every time. That's not always an easy ask depending on what you're doing. In some cases it is, and what we were doing it wasn't. I really got into editing JSONs because they could spit JSONs out for me pretty easily. And then I'm like, okay, I'm just changing file pathways and text, and I'm copying this chunk of code here and duplicating it down here. So that's when I really got into it. It was really to help them so they could focus on coding and not all these silly content requests from me as a project manager. Coming back into academia, what I'm seeing is if you really want to do a good job with things like statistics or making really great figures, you're going to need to know some code. I'm realizing that I have a big weakness by leaning on GUI based programs all the time. Like there's just some things that I can't do unless I learn to code better. And then you and I have spoken offline a little bit of me really wanting to get into machine learning. And the more I learn about machine learning, the more I'm seeing so many applications that I can just see the writing on the wall. If I can't get just some beginner coding, just a little bit of Python under my belt, I'm toast long term.
Are you familiar with the phrase copying and pasting from Stack Overflow?
I am not familiar with the phrase, but I know exactly what that means because I've done
All
it.
right, sure. Well, you're on your way then. That's a big part of what it is. Although that's evolving these days, it's maybe asking ChatGPT to rewrite your code for you or to implement a to-do statement you've written as a comment.
Yeah, and I've been playing with that. I asked ChatGPT to spit out a shell script. I have to upload a lot of files for a project I'm working on to Microsoft OneDrive, which is not ideal. And there's a whole bunch of bureaucratic reasons with my university that I have to do it that way. Like, I'm like, why? Why don't we have like an FTP? So anyway, carrying on. So I was able to get a shell script out of ChatGPT to upload the files one at a time, because if you batch upload them, you tend to get a lot of errors with OneDrive, especially if your file sizes are too big in your batch. So if I can just do it one at a time and leave, that's great. So I got everything up and running, and then lo and behold, more bureaucracy. I found out all the university computers disabled shell scripting. So anyway, but ChatGPT was able to spit that out pretty quickly, and it was simple enough that I was able to look through it and say, okay, it's got the right destinations, it's pulling from the right place. I can see it's doing one at a time and then it's cycling through until it's done. So for me, it was super helpful to just generate the code, get all the syntax figured out, and then I could check the big stuff and then test it and make sure it's working. I mean, hypothetically, if my university didn't disable shell scripting.
I share your frustration. I've been in similar situations. It's not no better in the corporate world. There are times when it's made very difficult to get the access you need. What have been some of the biggest challenges in learning to code and advancing your skill?
So for me, it's a practice thing. because I'm analyzing data maybe once every couple months. It's not something I'm doing every day. If you have a class, maybe you're doing it a couple times a week. So without that practice, I'm not learning some of the basics. I'm continuing to have to look things up. I'm just going to use R as an example because I think a lot of people struggle with this particular problem. If you're not loading in a data file and making sure the data frame is being read correctly, if you're not doing that frequently and getting a lot of practice, especially with different kinds of data files, you're continuously having to look that up. And you're wasting your cognitive energy and overhead, which is limited at any given session where you're trying to code, on just getting your file into the darn program. So for me, I'm finding that without that consistent practice, I'm often getting stuck relearning the basics of coding. And that's kind of where I'm at. So I don't know, the best way to deal with that is that maybe to have little side projects where you're practicing a lot, or making my own notes that I can always refer to, keeping like a good coding log, like this is how you import this kind of file. I'm not sure what more experienced folks do to make sure that they're not constantly reinventing the wheel.
I think it's all of the above. Honestly, I think there's a great part of the craft that is just the art of copying and pasting, but knowing how to quickly find the thing one needs to copy. So I've worked on some bigger projects that maybe they're done or I'm not on them, but I'll keep something around because, like a utility file that I built there, I'll copy that over. That for anything that's complicated but common, I can just copy and paste that same function. I know how to use it. I pass in an array and I get back whatever I needed. And it's perhaps, 20 obfuscated lines of code that I could muddle my way through, but why spend the 30 minutes? Just have it.
And I have some of those things for, especially for like basic statistical tests, but I find I'm often running into edge cases where, oh, yeah, you have the code here, but your data file is slightly different than what you wrote.
Uh-huh.
And I imagine a lot of people are dealing with things like that. You're constantly having to modify and evolve what you wrote.
Yeah, it's something that I think a lot of people will find you shoot yourself in the foot if you're not careful. And I think those that are successful end up developing a style where you'll, if you can, materialize the data frame you're going to run with. And so you can always track back, the exact data. And in the source control, you have the exact commit of the code you were working on. And at least that should be reproducible. And then if you manage using Git very well, you could even know the exact older version of the code. So if there's ever a question, you should be able to, if you use the tools the right way and are a little bit meticulous, kind of a perfectionist level of thing, but you can set things up in such a way that you could always say, what is the full provenance of this output? And know I got it by running this version on the code on this data set.
That would be nice because, especially with R and now Anaconda, versioning for the packages you're using is a pretty big deal. You
Yes.
could get weird errors just because you're using a newer version of whatever package. So that makes sense to me
They call it dependency
because you don't
hell.
always, yeah,
Every language has its own
yeah,
version of it.
yeah. Oh, I had a professor that set up a cloud instance of R that all of us had to log into. So he controlled the dependency hell, and that's one of the smartest things I've ever seen a professor do for using R in a
Very
class.
nice. Yeah.
So we never had to load any packages on our own. Another challenge I've noticed in coding classes is you'll have about a week or two, or if it's a workshop, a day, where you're manipulating little strings of data and you're learning all the basics of like, how do I transpose this and flip flop rows and columns, or how do I do some basic mathematical functions, or recode this from a string to some other kind of variable. And those for me often go too fast. And for me, that stuff is actually more important than running a complex function because I can usually find the code for something really complex. But if I can't do the basic things to set up everything to get ready for that big complex function, then I'm stuck. So I'd say that that's another thing that if I ever get good enough to teach this, I think I'm going to hammer my students with all the basics more than the complex stuff because they should be able to figure that out on their own if they could get the basics. But that's something I've definitely struggled with, is not getting enough practice with the basic skills before moving on to more complex things.
Yeah, it's perhaps counterintuitive, but true. The whatever the core thing you're going to do, maybe it's machine learning or a principal components analysis or some core methodology. 90% of the work is getting your data in order to go to the library that does all the real heavy lifting.
Yep, totally. That is a place where I think a lot of students get stuck.
Yeah, you're going to write what we call glue code most of the time.
What's glue code?
Oh, it's sticking things together.
Oh, yep. Yep.
So, okay, you were able to read an Excel file because you know how to do that functionality, but then it comes in weird columns. You can't pass it directly to some library you want to use. You've got to do the data transformation. That's some glue code, sticking those two things together.
I've also had packages that'll say your data needs to be an XYZ format or file extension, but then I can't find the function to get it there. So that's occasionally or it won't tell you that. It'll give you an error that's in some really arcane, I would call it coding language, that I have to go to Stack Overflow
Yep.
and search for sometimes quite a while until I find someone who explains what the heck that error actually means. This is nice. I'm getting to air all my grievances with coding.
Sure, yeah, these are the behind the scenes stories that people, everyone says how great of a coder they were and they were a natural. I don't think it's true of anyone. We all hit these same headaches. The completely obtuse error message that does not at all make clear what the simple problem is.
Yeah.
Well, I would recommend, in addition to Stack Overflow, give ChatGPT or some other large language model a chance to solve it. Even just copying and pasting the exception will often give you a surprisingly articulate response on how to fix it.
Yeah, and this is one area that I've been actually embracing ChatGPT and other LLMs because I'm constantly trying to get my students not to use it for writing and like answering questions, and because they need to learn the content and critical thinking. They're just at a different stage. But I'm finding for actually solving like coding problems, that's a whole different ball game in my opinion. So I've been more open to using AI to solve those kinds of problems.
Do you have any advice for someone maybe more novice than yourself, someone literally at step one? Where do they start coding?
So I actually really liked looking at CSS and HTML, even though it's not technically code. And the reason is because it tends to be a little bit less specialized. There's a lot of more common, like lay language in the things you're trying to do, and you can see your results right away. So I liked starting there, playing around with web stuff. I also really like taking other people's code that's really good code and tweaking it in a safe way. I'm not working on real data. I'm just playing with something. So I think play is the big thing here. To my detriment, I like playing with programs on the computer, and sometimes I'm almost a little too aggressive about what I'm doing and clicking around and playing with code because I break things sometimes. But I think getting over that fear of I'm going to break it, because you can always start it over, you can always go back to a different version. I can't say I've ever truly bricked my computer, but I guess I've occasionally had to reformat just messing around. But yeah, try to lose that fear of failure and breaking things. And then I think web design and that kind of thing is actually pretty good entry. And I'm also finding in my journey here that shell scripting has also been a really good entry. And then after that, I think I'd like to dive more into Python again.
Yeah, good path, I would say.
In 2023, just 10 vulnerabilities accounted for over half of the incidents responded to by Arctic Wolf Incident Response. Wouldn't you like to know how to take them off the table and make life more difficult for cybercriminals? That's just one of the essential insights you'll find in the Arctic Wolf Labs 2024 Threats Report, authored by their elite team of security researchers, data scientists, and security development engineers, and backed by the data gained from trillions of weekly observations within thousands of unique environments. This report offers expert analysis into attack types, root causes, top vulnerabilities, TTPs, and more. Discover the attack vectors behind nearly half of all successful cybercrimes, why ransom demands climbed 20% from 2023, and find out why 2024 will be an especially volatile year for cybersecurity. I got my copy. You should get yours by going to arcticwolf.com/dataskeptic. That's arcticwolf.com/dataskeptic.
My name is Malia Guillen. I am an associate member and principal investigator at the Donald Danforth Plant Science Center.
And can you share a few details on your role there?
I run a research group of about 9 people. They're very diverse in their background expertise. We have everybody from biologists to biochemists to statisticians. We have somebody with expertise in entomology. But what's common is that there's an interest in improving crops' resilience to climate change.
And to what degree does programming play a role in that research?
A huge role. So my lab, again, the focus is on answering the biological question, which is how do we improve crops to climate change? But we do that by measuring natural variation. And the way we measure natural variation is to analyze image data. And so we're trying to extract important plant traits from pictures of plants. And that means we're doing a lot of computer vision, which requires programming.
Where is the first line of code for you?
As a graduate student, I used other people's software when I had to analyze RNA-seq data. And as a postdoc as well, I started to use other people's software out on the internet, open source software. But my first line of writing code was when the Danforth Center, again, built this large robotic phenotyping system that collects thousands and thousands of images every day. And I was a postdoc tasked with figuring out how to get all the information out of that image data. And so I had a problem and we needed to solve it. And so we went out and looked what was available open source. And there were some great packages like OpenCV, but it didn't meet all of our needs. And so that's when we decided to start exploring software development.
Well, OpenCV, for listeners who aren't familiar with it, could you share some background in why that library stood out for you?
So OpenCV is a really powerful computer vision package. And many people in the computer vision space use that package very actively. There's another package that's called scikit-image that is also very powerful, and we use that package as well. But again, it's open source. And so what that means is that anyone can use it. It has a very permissive license. You can build on top of it. And so that was very attractive for us. It is also very well documented and widely used in the community, meaning there's a lot of Stack Overflow posts about if you have a problem or you need to troubleshoot. And so there's a really active community surrounding that package, which is very attractive.
Yeah, definitely a powerful and widely used tool, but one that wasn't just perfect enough for you guys. Could you talk about the limitation and what that drove you to?
Yeah, I think it's really powerful, but the focus it's probably sort of targeted towards those who have a little bit of background and expertise in computer science or computer vision. And for us, we were biologists by training, and we spent a lot of hours sort of sifting through and learning how to read and use OpenCV, but there's quite a bit of a learning curve. And so we wanted to make this more accessible to biologists and those that might not have as strong of a computer science background.
And what does PlantCV do?
So PlantCV is a computer vision software package targeted towards plant science, but is used for other applications as well. We have been developing PlantCV openly for over 10 years now, with the focus of extracting meaningful traits from plant data. But at its core, it's supposed to be modular so that you can kind of hook pieces together to analyze whatever image data you might have.
Were there any learnings in the development of that about just coding in general or how to make your code accessible to other people?
Absolutely. So I have the advantage of having a very long-standing collaborator who is an original co-developer of PlantCV, Noah Falgren. We started as postdocs together at the Danforth Center, and we're still here at the Danforth Center and continue to collaborate and develop on PlantCV. But what I want to say is that, we started very naively. We had a problem. We needed to solve it. And so the first iteration of PlantCV we put out on GitHub, 10 years ago now, and it was maybe a few hundred lines of code. That, we didn't have code testing built in to PlantCV. That came later. It was always open source, but we needed ways to make it more sustainable. We always had documentation, but we needed to make documentation easier and more accessible to people. So that included adding interactive documentation so people didn't need to download PlantCV in order to see if it would be possible to analyze their data with our software. So there are a lot of infrastructure steps that really Noah spearheaded that were really important to the sustainability of PlantCV and its use as a community tool.
And where do you consider yourself on the journey from complete novice to expert programmer?
I'm probably somewhere in the middle. So I've been doing this for a little over 10 years now, and I really enjoy it, but it's not something I can do with 100% of my time because I'm running a research group. So I love doing it because it's something I can pick up and solve a problem, but then I can also move away from it if necessary because I have something else in my life that's sort of taking over.
Do you have an affinity for any particular languages or tools or things like that?
PlantCV is written in Python, and that was done very intentionally because we felt it was probably going to be the most accessible to biologists in particular. We also do most of the downstream statistics in R. So Josh Sumner, a very talented statistician who is part of Noah's group, has written a companion R package to PlantCV called PCVR, so PlantCVR, where we're trying to streamline a lot of the downstream analyses that you would do in R.
And could you share any of the biggest challenges you had when learning to code?
I think had always an interest in coding, but I think the challenge is that you really need to have a problem that you care about so that you have the time and the dedication to solving that problem. And you also have to let yourself struggle a little bit. I think there is sometimes a knee-jerk reaction to feel like you have to get something right the first time. And that's really not necessary in programming. And I think there's an intimidation factor as well. So I like to tell people, don't be scared. You can't break things. It's pretty hard to break something. When you're programming, the worst thing that usually happens is that it doesn't work. But sometimes it's really hard to get over that mental barrier when something doesn't work sort of over and over again. So that, I think, is a challenge. But also, it's really nice that in terms of programming, like, you have to think, like, it's really advanced Googling often. And some people are a little afraid to Google a problem until they feel like they can't go any further. So that was a challenge at first getting over, but now it's something that I really actually like about programming.
Have the large language models or GitHub Copilot or any of these new AI tools had an impact on the way you code?
So large language models are incredibly powerful. Some of these new generative AI tools are really, really interesting, like DALL-E. So we are exploring a space where, especially in plant science, where we don't have a lot of labeled data. And so the opportunities we see with tools like DALL-E are really interesting because maybe they'd be potentially in the future when they're maybe a little bit more developed, maybe it's possible to create synthetic data that's realistic enough that you can then use it as labeled data. Often the problem we have in plant science, again, is that we don't have a lot of labeled data. So the easier it is to segment our target object, which in this case is plants, from any background, any tools that make that easier are really interesting to us. And so those are things that we're actively exploring.
Do you have any advice for people?
I think my advice would just be to find a problem that you care about and to go for it.
Thanks to our sponsor, the Georgia Tech Scheller College of Business. Check them out at techgradcertificates.com, especially if you're ready to become a data-savvy leader. Did you know the Georgia Tech Scheller College of Business is ranked a top 10 business school in the U.S. for business analytics? They offer a 100% online business analytics graduate certificate program. There's 4 courses covered: business analytics for managers, machine learning for business data preparation and visualization, and analysis of unstructured data. This graduate certificate is designed for professionals in any industry that want to become data-savvy leaders or just pivot into analytics. You can maintain a work-life balance and other commitments while going through this flexible graduate certificate program at your own pace. And that certificate can be your gateway to a Georgia Tech MBA. So if you want to stay ahead of the game and learn key strategies to extract information from the vast amounts of data generated every day in business, consider pursuing the certificate. Applications are open for the fall of 2024. Get started at techgradcertificates.com.
John Wellness. I'm the Director of Research Engineering at Symbolica AI.
And do you want to share a few notes about what Symbolica AI does?
So we're actually somewhat relevant to maybe some of the topics of this conversation. We're building new foundational models, and in particular, one of the application areas we're targeting is code synthesis, facilitating generation of code and helping people become more effective as software engineers.
Very cool. Definitely an opportunity there. I could tell from some of my own uses of it. Well, we're talking today about coding and people's journeys through coding. And I'm going to ask everyone the same first question, and that's, when is your first line of code?
Well, it must have been TI 83 basic in middle school. I wrote quite a bit of TI 86, or what was it, TI 83 basic back in high school. And I started branching out into other programming languages, other environments, because there's like clear limitations to what you can accomplish on your calculator, and I kept running into those, and I was like, well, gotta find more powerful environments.
Were there particular things you were trying to do that you were hitting a limit on, or is it just the ergonomics of writing for the calculator?
There's really limited ability in that language to write reusable or modular components, or like, yeah, I mean, it's a very basic, hideous mess that's, useful for writing some macros. But, I would write some solver for some kind of math problem that I had, and then I wanted to add more features, and then it's not really possible at some point. That's how I got into programming. Of course, underlying all of this was that my older brother was into writing software and coding, and so I, of course, wanted to do whatever he was doing.
Also nice to have a resource.
Yeah, for sure, yeah.
And can you tell us a little bit more about your journey into coding from the early calculator days? Any interesting stops along the way to where you're at today?
I thought for a little while that I might want to go directly into software engineering, but I got hooked on math, like abstract mathematics in undergraduate, and started focusing on math research instead. And the programming that I did, the coding that I did, remained for a very long time what it had started as, which is a utility for my mathematics work. I would write Python scripts to test some hypothesis, or run some simulations, or just throw together something to. Sometimes you can save quite a bit of thinking by just seeing how stuff actually works when you write it down in code. That was for many years basically the only thing that I was doing with code, and mostly in Python. It was really based on my mathematical interest that I started to move into the direction of researching stuff in theoretical computer science and theory of algorithms. And at this point, it's mathematical work, right? It's not a lot of coding that's going on. It's more, you might test some hypotheses or something by writing together some scripts. And it wasn't until later on, when I started moving into theory of deep learning, that I started to get more serious about actually implementing larger scale projects that required more sophistication there.
Have you ever taken a look at the programming language Lean?
Yeah, that's a really cool framework. I'm not an expert in Lean.
I've been meaning to talk to one, but let's warm it up.
Yeah, Lean is a great environment for interactively producing formally verifiable proofs. There's a number of these, but Lean has a really great interface. There's a big gap, generally speaking, between what a mathematician writes down as a proof and what can be interpreted by a formal system. Research level mathematics is mostly not happening in these formally verifiable languages. But part of what Lean does is it makes it easy enough to express powerful constructs that you can start to move in the direction of like the frontier of mathematics. Right? This is actually another area that my current company is actively working on, is being able to build deep learning systems for exactly producing these kinds of formally verifiable proofs in languages such as Lean.
And we'll cut this if it's something you're not comfortable going into, but I'm curious if you could expand upon that. Is it like a search for novel new proofs that we've just missed within what is expressible for Lean, or what direction can you take it?
Ideally, you'd like to have a much more powerful computer proof assistant, or even models that are capable of, performing at the level of a research mathematician in proving theorems, right? In developing statements, hypothesizing things, and then producing the entire proof. We're pretty far from that still as a community. Part of the bottleneck here is, as you know, a lot of the frontier models thrive on massive amounts of data, just absolutely mind-boggling quantities of data. It's very difficult to get that for these like formal languages like Lean or MetaMath or whatever. It's not to say that there isn't any. Like there are substantial libraries of proofs and theorems that have been expressed in these formal languages. It's just that substantial in this case is nowhere close to the quantities of data that GPT-4 is trained on or whatever. Right? For the most part, these theorem libraries or proof libraries don't come close to the actual frontier of research mathematics in their content. There's just too much to write down, and it's so expensive. It's still quite laborious to produce these, even with high quality systems like Lean. You still need an expert really deeply involved in the loop of proposing proof steps and simplifying things. And so it's very difficult to get data there. The current state of the art is, for example, there's this paper, Lean Dojo, by Anand Kumar's group. I think they got somewhere in the vicinity of 50% ability to, for 50% of theorems in their sort of withheld test set, they were able to reproduce proofs by combining some deep learning model with the built-in heuristics of Lean. So there's a big gap, and that's not the frontier of math. That's nowhere near the frontier of math. That's like the stuff that people have had the time to express. So there's a huge gap between what we can do right now in terms of proving stuff and what we would like to be able to do.
I hope I'm not underselling it in my analogy, but I know you and I both write in LaTeX, and it's kind of, I find it archaic.
Yeah.
I always struggle to really keep it top of mind,
Mm-hmm.
but the modern large language models are excellent at it. I tell it what I want, I tell it to make a change, and I get the LaTeX I need right away. So having it as my assistant has revolutionized my ability to write LaTeX documents.
Yeah.
And perhaps mathematicians can experience the same thing.
Yeah, at some point, yeah. I mean, it's a lot easier to get data for LaTeX, right, than for
of course,
for these theorems. So that's one of the big gaps. But I think there's a big opportunity there to make for more progress. Yeah.
And can you describe your current tool set? How do you code when you sit down to do it?
For a long time, I was just writing in NeoVim, and I mean it's a modern Vim. Writing the terminal, writing my Python scripts, and I spent a lot of time on my Vim key bindings. But these days I use VS Code. It just integrates nicely with the kind of production processes that we have for being able to test code and start experiments and integrate with GPUs and stuff. So yeah, I'm writing in VS Code. For just hacking around on experiments, I often have a Jupyter notebook open in VS Code for that, and I like the interactive flow for testing stuff out. It's convenient to be able to get sort of instant feedback, inspect variables. You can do some of that with the Python debugger with a bigger script, but it's just less friction for.
Yeah, I follow a similar path. You get a little bit of a headache then when you want to migrate it into some .py file, but I find it's well worth it.
Yeah, absolutely. Yeah. So usually what I'll do is if there's some algorithm I want to implement or some architecture I want to test out or something, I'll hack around with it in the Jupyter notebook before exporting it then into more structured modules that I can call from my other notebooks.
Were there any major challenges you faced in getting from the calculator to where you are today?
I mean, it was such a long, so many years that you don't really notice it. I had a lot of time to grow, in other words. One of the bigger challenges I remember facing in recent years was when I was just sort of transitioning from I'm hacking around when I need to, writing a quick script in Python to test some experiments, to, well, I need to write bigger, cohesive, deep learning modules using these tensor frameworks. That required sort of a step up in terms of interacting with lots of other people's code and learning how to be comfortable with diving into the guts of what other people are producing, rather than just interacting with it via an API, but like really taking and modifying. And other people have different conventions, and it's not necessarily practical to re-implement everything from scratch. But also in the deep learning community, you need to be able to understand and read and get comfortable with what's going on in the guts of something that someone forked from something that someone forked from something that so that was sort of a challenge. I think, it's not just producing code that I'm comfortable with and understand, but also becoming better at consuming and adapting to and understanding and drawing from code that is not necessarily particularly well put together or structured. It's also academic research projects. A lot of it, it's not necessarily meeting super high stuff, but you still need to read it and understand it and get to grips with it. So I had to get a lot more comfortable with, for example, the Python debugger, and stepping through code and understanding how to inspect something, just to writing tests for particular cases. But all of this stuff is the nice thing about coding, about software engineering, is that it feels fundamentally tractable in a way that a lot of research isn't. Coming from an academic background, there's lots of problems where you don't know in advance if you're going to be able to solve them or not, if you're going to be able to come to a solution. But for me, coding and software engineering in general just feels a lot more tractable, in the sense that there's always a better solution. Things could always be cleaner or more performant, more efficient, but you can break stuff down and solve it with enough elbow grease.
I would call that good advice, but my final question was going to be, do you have any specific advice for people getting started? What are the best ways to get into software engineering?
I think the important thing is to know what it is that you're trying to do. Software engineering it's so big, right? There's so many different directions you can go, so many different languages, so many different toolkits, so many different styles and outcomes. It's easy to get lost and overwhelmed if you're not clear with yourself up front about why you're doing it and what you're hoping the outcome is, right? If what you want to make is, you really want to make an app on your phone that's, this really cool idea you have, it's going to be a neat business or whatever. That's a very different kind of need or problem than, this is a real pain that I have to do all these processes manually for my job, and I'd like to automate them. And that's, again, a different sort of task or problem from, I'm trying to do research on database systems or deep learning or whatever. I think you need to start from a clear perspective of what it is that you want, what you're interested in, what you're trying to do. And I think there's not a universal advice then, but depending on where you're going, there's nothing better than having people who are learning with you, people who are in a community with you of folks who are facing the same challenges, who are also people who you can teach and who you can learn from. I think that's a really powerful way to develop new things. But where you find that community, that depends on, what's the problem you're trying to solve.
And can you describe any ways that large language models have influenced the way you do your work?
It's funny. I'm doing stuff, very closely related to and building off of large language models. I don't actually, in my work, get a lot of value out of them. For a lot of use cases, there is value, but my experience has been that they aren't reliable enough or produce high enough quality outputs that I can depend on them. And so they don't actually save me effort. That's part of the motivation for trying to do things better at Symbolica. I think there are very good use cases for existing LLMs. Particularly for code, if there's some software package you've never used before, and you're not sure where to get started with it. In the Python community in particular, one thing that I find is that There's lots and lots of really great documentation. People tend to be really good about like documenting their APIs for not universally, but there are worse communities in terms of like producing high quality documentation. But it can still be the case that if you're just coming into a new project and you're not sure, it seems like this would be a good software kit to use, but I'm not really sure how to get started, then natural language queries to, GPT-4 or whatever can be a great place to get situated, right? I want to do this. What's the right place to look? What are the right sort of API calls? And then you can read the documentation and sort of, get to grips with it. Or here's a snippet of code, maybe a small block with a bunch of API calls that I don't understand. What's going on there? Can you unpack this for me? Those sorts of things can be really useful. If you're trying to produce long form, more substantial blocks of code, though, without first like trying to understand what it's doing, that's where you run into issues with these LLMs because they can hallucinate API calls. They can do things in like really weird, inefficient ways that aren't then maintainable. So I think in terms of like growing your own understanding, it can be super powerful. In terms of like replacing the work of actually having to understand code, that's where you run into trouble. As I said, there's no universal advice, right? It's like you got to know first what you want to do. But in terms of if there was something that particularly would speak to what Becky is looking for, or what are questions that she would want addressed, or
Oh, well, that's interesting. I guess I don't want to put words in her mouth, but my understanding is she's, truly a biologist. She doesn't want to career switch here into computer science. Maybe we'll get a hold of her and we'll bring her to the Church of Turing. But, in the meantime, she wants to know just enough to do her work and support things she's into. And I think perhaps she's recognizing that the tool set is changing, in particular around computer vision. So, there are loads of grad students these days that are manually counting ants and tagging them and marking them up. This, laborious process. We're pretty close to letting the computer just do that for them. So now,
absolutely.
What science can they move on to in advance and stand on the shoulders of that?
Yeah, absolutely.
And how do you be prepared for that?
Yeah, absolutely. Yeah, it's funny. My wife, Madeleine. So she's a biologist, and she wrote a textbook, Computing Skills for Biologists. So it's just co-authored with Stefano Alesina at UChicago. And they go through things like, Python, and then all sorts of data visualization things, R and statistical analysis stuff. Of course, it's dangerous writing a book like that because the field moves so quickly that things get outdated quickly. But I mean, she came from a very similar sort of perspective and background of, I want to think about plants. Plants are really cool. I want to understand all the questions that I have about plants, and how can I let technology be a facilitator for that? It's not that I want to do coding per se, it's that I want to solve my problems, right? I have particular problems about analyzing data, organizing stuff, being able to do stuff in reproducible ways that are important in science, right? That's definitely its own particular set of challenges. But I think there's certainly a lot of scope for augmenting, as you say, particularly stuff with computer vision. I know Madeleine, when she was doing her postdoc research, she hacked together some stuff in R to be able to process all these images that she was getting of plants to be able to compute, surface area of, disease on leaves or whatever. And I think that's probably a lot. You would have a very different flow of doing that these days with sort of pre-trained.
All right, I hope everyone enjoyed those 3 different points of view on people who are actively using coding in their day-to-day lives. As we touched on several times, the large language models are having a significant impact. You should always have a coding assistant going forward, although the ones we have today have their limits. But they're great at the tedious stuff, and they're faster than a Google search. They'll usually give you working code you can copy and paste. But there's something more fundamental I want to point out to people, especially people coming from the sciences. Your code is almost certainly sloppy. Don't worry too much about that. But what you do want to get good at is Git, G-I-T. It's a form of source control. So even if you're just working by yourself, well, let's say you start a project. It's just on your home computer. First of all, your home computer can die.
and then you lost your project. We'll solve that in the process here, don't worry about that. But if you just start creating files and then running them or using them, software evolves. At some point, you're going to break your software. You need a good way to roll back, and that's not always going to be easy if you try and do a big swinging for the outfield sort of change to your code, some big refactoring. Code evolves, and you want snapshots in time. That's the first thing you get as a solo developer. If you start collaborating, you get tons of added benefits that you can learn about just about anywhere. But I also want to say something about the way people use Git. Maybe this is anecdotal, but the majority of people I've worked with in my entire career are super sloppy with source control, and it hurts them productively. It's a small little chore to double check your commit. Don't just do git add dot to add everything. It's sloppy for all the obvious reasons and the security problems if you accidentally add your .env to the repo or something like that. But you're ignoring a great feature that the source control gives you. If you do something like a git diff on every file modified, first of all, just do git status. You get all the list of modified files. Go through them. Did you mean to make that change? Do you really want to have set auth equal to false? Or did you just change that for local development? You will save yourself embarrassment and heartache if you check every individual file before making a commit. Take it seriously. Do a nice job with source control. You will thank yourself later. And it's not hard to learn. Second tool you need are notebooks. Jupyter Notebooks. There's a bunch of commercial versions of these. Some sort of browser-based interface where you can have code cells. You can run them out of order. You can make a real mess in there. But you can also inline write text and make graphs. Now, unfortunately, those don't work well in Git. That's a challenge for another day. But you can still version control your notebook, sloppy though the diffs are. And you should be proud of your notebook, assuming you have a nice result and all that. But realize that notebook is not exactly code. If you want to do something with that beyond your analysis, it's going to take a lot of steps. How is it going to be turned into quote-unquote real code? Where is that code going to run? Who's going to support it and maintain its infrastructure? Ideally, you should have a collaborator to throw that over the fence to if you're a hardcore scientist. But if you lack that resource, or that resource just doesn't want to help you or doesn't have the time for you or whatever, I suspect most of you will find yourself doing some of this alone. You'll need to learn a little bit of software engineering. Luckily, the libraries and boilerplate code and stuff that's out there is super great nowadays. You do not need to reinvent the wheel. But you do want to eventually learn about unit tests, and that's the last little anecdote I'm going to wrap up with today. A unit test should appeal to the mathematics folks as well. Not pure math exactly, but it has a mathy feel. And the philosophy of unit testing or test-driven development, it's really clever from an engineering point of view. The idea is that you don't write any code initially, not the real code you're going to run. You start by writing test code, and the test code checks some condition of your software. So if we make the analogy to a car, then one property of a car is that when the doors are locked, I cannot open the door. You write a test for that. Then you write a test that says if the doors are unlocked, I should be able to open the door. So you write those two tests, they should initially fail, because you haven't done anything with the lock yet. Then you go implement the code to make sure that test passes. You don't write any extra code, just enough to get the job done. Then you keep defining properties of your software, and you assert them through some sort of test. This way, if down the line you ever make a change that accidentally breaks something you didn't think about or didn't intend, or your collaborator does that, some of these tests are going to start to fail. Aha, brings it to everyone's attention. A suspicious change was made to the software that broke something that used to work. Or perhaps we should say, change the functionality of something that used to work a different way, or was presumed to work a different way. Maybe the test needs to be updated. Either way, you've got a very formal process, and if you can declare that you've got 100% code coverage, that is to say a test checks every line, that's not a guarantee your software is perfect, but it's a huge accolade. These couple of formalities as you move along down the road will probably help you greatly. Get good at Git, be comfortable in notebooks, and realize they're not production code, so when you think about production code, think about unit tests. That's my quick fortune cookie wisdom for you. Thanks for tuning in, everybody.